just I'll borrow three of them just to reinstate what John has mentioned. Actually, what we actually been doing and what we were doing with the SnakeMake yesterday, right? So essentially, when you think about bioinformatics tasks, which you all been doing, you can think them as workflows, right? And that's what Phil emphasized yesterday, and the same thing that John has emphasized is that you got an input. They could be reads, they could be data, whatever format they are, and we want to do something about it, and we are going to use one or several tools, right? In this case here, really nice slides from someone in Australia, and I'll keep a link to those slides. They're using CutAdapt. They're going to use FastQC. If you use this is a QC quality control for mostly reads, and BWMM, which is an aligner, and mark duplicates, which are assuming that they are going to, find duplicates and mark them. Okay, so this could be from GATK or something, and out will be an output. It could be one single output or several outputs, and also a log file. Okay, I like log files just so that you know what your script is doing and you can troubleshoot. And technically, that is a workflow. Okay, so it turns out that there are certain aspects of this that are standard and that you can generalize. Okay, and that's what we're going to do. So, oh, sorry. Right? So, you've got the workflow, which is this computational pipeline comprising of multiple tasks, right? And we got a tool which does and performs a specific task, right? And that's not necessarily true because I know some of these tools do more than one task. Okay, which brings me again to another concept about bioinformatics tools and creating these tools that do so many things. Okay, the Unix philosophy, and you've been using Unix tools. Often one tool does one job and one job only. Okay, the so-called simple tools. Okay, so in this case, we got these tools, and it turns out that we can create a workflow language that we can use to implement these workflows. So if you really look here, the thing that most changes is the input. Okay, and you got a sort of iterative improvement of these tools. Okay, year after year. Okay, and we got a problem because when you have CutAdapt version 0.1 and CutAdapt version 2, they can give you different outputs. And we just say, well, I took my read, I used CutAdapt, and I don't specify what version it was. There's a little bit of a problem. Okay. Secondly, I don't want to just be doing this over and over. If I can just write one thing, know that I can run that multiple times, then it becomes inherently really, really easy. So comes a workflow language, which essentially is to try and describe this. Okay. So the last slide here, we'll try to show a basic sort of a script, and I'm sorry this is not very visible, but essentially it's a shell script. Okay, so in a shell script, you define your inputs at the beginning, and you got a couple of things. So these things here will need to be manually specified because they tend to be places in your directory where your data are stored. Okay, so if I'm reading my genomic reads that I've stored in the name of the project name, I specify that manually, and that means that if I take my script and I give it to John, right? John has a different directory structure, so they have to change this where their reads are stored. Okay. The other thing is that we got to think about creating directories. So this script over here specifies some inputs, and then it says make dir -p, and then it creates these directories, presumably where this is going to happen. store these folders. And I can see their relative path names. You know, they start with, like, from where they're running the tool, the directories will be in the previous directory. Okay? And that's not necessarily how I structure my directory as well. So again, we got that. And then the other thing they're going to do is that they're going to load the tools needed to run this script. Okay, so I can see they're using the module system. Therefore, they're doing module load, NCBI, NPI parallel. I can't read that. Some tools and a couple of, whatever, couple of tools to do this analysis. Okay. And they're going to handle their parallelization. I can see they got OpenMPI. So for those of us that are familiar with OpenMPI, it's a tool for running parallelizing jobs on a HPC cluster. Really useful. Okay. So they're going to, do that, and you can see that they got a script here that runs on their PBS cluster. Okay. And those are the that is their directory, and they've written all these scripts, and then they execute it, and this script is going to run. Okay, so it turns out that if you get that sort of structure, right, you can do all this in a bash script, but it's not very reproducible, right? So our workflows are aimed. Sorry. So it's reminding me. Yeah. So our workflows are actually aimed at generalizing those concepts and having this, and we can implement them in Nextflow or SnakeMake, or if you like CWL, which is actually a standard, a common workflow language that defines, and maybe I don't know whether we have time, but I might talk a little bit about it, which is simply a way to define a workflow's inputs and does not necessarily tell you what those tools are. They could be anything. So as long as I can find a way to document, to describe my workflow using standard terminologies, it turns out that I can just run that, and if I have an engine or something, those scripts will work out. And now what is happening is that a lot of these common workflow standards and engines can actually write for you an entire SnakeMake workflow, because it's so well defined. Okay, but then the language required to describe these tasks is quite difficult. It's quite tough. So, and it's prone to errors. If you want to do it, but then you got tools like Galaxy, where you, and I know, we don't have time to describe Galaxy, but then Galaxy just allows you to do drag and drop. And if you use a tool like Nine, if I remember correctly, I've not used it in years. I don't know if it still exists, but basically it's a drag and drop. Okay, so you say, you got a tab, and you take it and you drag it, and you describe your input and so on, and basically you graph your workflow. Okay, and you can say generate CWL. Yeah, out of it, and all the taskness and all that you've done, it will emit a CWL. You can also actually ask it to describe or emit for you a Nextflow workflow. Okay, but knowing how to write these tools by yourself gives you an added advantage, because those graphical tools are not as flexible, and therefore they need to sort of describe these workflows. So essentially that's what we are doing, and today what John was telling you about the channels is how do you consume this input, okay? Because it has to be described somehow, somewhere, right? And the concept with Nextflow is that you have this idea of channels, which technically you can think about as paths on how you actually do this, and then you run your analysis, and then you do and write your output, and you can encapsulate all that within a container, okay? And run that container. It contains all the, it encapsulates all the tools, the data, and that becomes very portable. Yeah. So again, now I think we will be better off trying this through an exercise and following through the resources that John will give us. Okay. I hope it's clear. Yeah. Thank you, John.